Right, let's get started. Hello, everyone. I'm David. I'm gonna be co-hosting this Outside the Bounding Box series, specifically on LiDAR annotation for 3D precision. So, as mentioned, my name is David Babushkin. I'm a technical writer here at NCORD, and I'm going to be co-hosting this with Leander Angst, who is our product designer. So just briefly going to go over the agenda for today. We're going to give you a brief overview of the NCORD platform and key benefits for using NCORD, why 3D annotation and LiDAR annotation matters. We're going to be giving you a live product demo of using NCORD to annotate 3D point cloud data, as well as some pro tips to make your labeling efficient and optimize your workflow. And then we're going to have a Q&A session at the end. So here's a brief overview of the NCORD platform. NCORD is a universal data layer for AI. What this means is we transform unstructured data into high-quality data for training, fine-tuning, and aligning your AI models. This is achieved through data annotation, data curation, and label, as well as model evaluation. Next, here's a brief overview of the role of LiDAR and 3D data. Specifically, 3D data can be acquired using a variety of different techniques. This includes LiDAR, photogrammetry, and structured light scanning. Once captured, this data can then be used to detect and classify objects in 3D space, supporting applications such as high-detail environmental mapping, such as topographic surveys or archaeological sites, and the safe navigation in robotics and autonomous vehicles, which of course has countless other downstream applications. Also, LiDAR annotation then provides models with a precise understanding of an environment's geometry, depth, and spatial relationships. The annotations teach a model to identify, to classify objects, distinguish between different surfaces, and then track objects in real time, which of course is then critical for building safe, reliable, and high-performance AI systems that operate in the physical world. As you can see here on screen, there are a few challenges that 3D annotation presents. Specifically, there's the complexity. 3D point cloud data is dense and contains a lot of data points scattered in 3D space. This makes the scale of point cloud data a challenge, since there are thousands of points spread over multiple frames, because point cloud data scenes have a time dimension, so that objects can be tracked across time. Finally, there's the challenge of occlusion to consider. This is when objects are only partially visible because they are obstructed by other objects. I'm going to now hand over to Leander, who will show you how NCORD is equipped to deal with these various challenges to produce high-quality 3D annotations.
Thanks, David. So I'm just going to go ahead and share my screen and we can jump into the product. Like David said, my name is Leander. I'm the product designer who's been working with the team to design a lot of the features in the tool that we're about to run through. So I'm really excited to show you guys some of the stuff we've been working on. Bear with me while I share my screen. Alrighty, so here we are in the NCORD platform, and this is a project page. So as we can see, just a 3D demo project, and this is my annotation queue, where there are a bunch of different scenes laid out, and these are my tasks. So we're just going to initiate one of these tasks, and this brings us into the label editor. So a bunch of different stuff going on here that we're going to cover one thing at a time. So on the left side here, this is my class panel. So for anyone not familiar with the NCORD platform, this is where my ontology will be represented, just in the form of classes. So we have a bunch of different class types here. There's the cuboid class, which I'm going to be showing you guys how to create shortly. And then there's a polyline and a point class as well. We're not going to use those in the demo today, but just to make you guys aware that there are several different class types that can be created inside of the label editor for a LiDAR project. And then this cuboid class, that's a general thing. So I've got one to annotate a vehicle, which is what we'll be using today, but you could also use cuboids to annotate something like a tree or just a random object. And then down at the lower left-hand side, this is where my labels are going to show up once I draw those labels. Moving over to the canvas, there are a few different screens here. So I've got my primary point cloud view here, on the upper left-hand side. I've got a top-down view. So this is just showing the top-down of the LiDAR vehicle itself. And then I've got all of the different camera angles that are coming off of the LiDAR vehicle represented across the bottom here. So for actually jumping into the point cloud itself, there are a few different ways that I can navigate around this 3D space. So if you guys are using a mouse, you can use your middle mouse button to press and hold. And if I do that, then I can swivel around the 3D axis like this. Using the right mouse button, you can click and hold that down. This actually lets me move around like so. So I can move around and then I can swivel. And then you can also use the mouse wheel to zoom in and out of the point cloud like this. If you prefer to use your keyboard, you can see a couple of keyboard shortcuts outlined at the bottom here. So you can use W, A, S, and D just to move around the point cloud like this, and you can use Q and E to elevate up and down. So the cool thing about these views is that they're all synced. So if we move over to this area on the point cloud, just to highlight that for everybody. So this is the bus that you see in the lower left-hand panel here. I'm just going to make this panel a little bit larger since that's what we're going to be annotating. So this is my bus, and we can see that if I move around on the bus here with my cursor in the primary point cloud view, the cursor moves around in the lower left-hand screen as well. And if we want to sync the tile on the right side to where I am in the point cloud right now, I can just double click on the bus here. So that's brought me to the top down view of the bus. And so now we can see that I'm moving around the top of the bus. And that is also synced in the primary point cloud view, as well as in the lower left hand tile. So now to actually create an annotation. To do that, I've got a couple of different options. So I'm going to start by selecting my vehicle class on the left-hand side. So I can either do that by clicking on it directly, or I can just use hotkey 1. I'm going to press hotkey 1. And now I could annotate this in the primary point cloud, but I actually really like doing cuboid annotations using the top-down view, just because it makes it a little bit easier to see if I'm capturing the entire area of the bus. So to create this annotation, and for anybody, if you're confused as to where I am, I'm in the right-hand side right now. I'm moving my mouse around circularly in the right-hand top view. So I'm going to click once, drag my mouse over, click again, and then I'm going to drag my mouse all down along the length of this bus. And so that's captured pretty much the top, or it's captured the area of the bus, but if we go back to our primary point cloud view over here on the left-hand side, I can kind of swivel around and I can see I'm obviously missing quite a big chunk of the top section of this bus. So now to actually adjust this annotation, I'm just going to click on the cuboid I've created. And this brings us into a special sort of annotation view. And there are a few different things going on here as well. So I've still got the primary point cloud view where I can see the cuboid that I've drawn here, but I've also got these different vantage points here on the right-hand side. So I can see the cuboid from the left-hand side, so the side view of the cuboid. I can still see it from the top down, and I can also see it from the front. So I'm just going to zoom out there a little bit to show you guys. And this is really helpful to see. It helps make me very aware of where this cuboid is in space. And it also makes it really easy to see which parts of the object that I'm trying to annotate I've missed. The other cool thing about this view is depending on the pane that I'm looking at. So let's focus on the front pane right now. This view actually highlights the points in the cloud itself that I may want to add to this annotation. So you can see that the points at the top half of this bus, they're not annotated, but they are highlighted. And so that indicates to me that those points they exist in this plane, and it just makes it really easy to see where the rest of this bus is if I'm looking at it from the front. So if I now want to make adjustments to this cuboid to make sure I'm capturing the rest of the bus, I can come back over here to the front panel, and you can kind of see that there are different sections of the cuboid that are being highlighted as I drag my mouse over it. So if I hover over just the top edge there, I can click. And then once I've clicked, I can keep pressing down and I can just drag this cuboid up to capture the rest of the bus. And we can see that that has been reflected in the primary point cloud tile as well. So now I've got pretty much the entire bus selected. I can double check just to make sure using my other views. It looks like I'm missing a little bit there on the side from the top down view. So I'm just going to drag this over using that. And then the side view of the bus, maybe I'm missing a little bit at the bottom there. So you can make any adjustments that you need. And then another cool feature that we've got is If we come to the toolbar here, you can see I'm hovering over this tool, and the tooltip there reads fit cuboid to points. So this is a really nice little shortcut that you can use, and that is just going to make the cuboid that you've drawn hug any surrounding points. So it's going to get rid of any dead space in between the annotation and the bus that I've highlighted here. So you can see if I press this, the cuboid has kind of snapped to the outline of that bus. It's a pretty cool feature and actually speeds up annotation time quite a lot. And then just to get out of this view, I'm just going to click outside of the cuboid. So now we can see that annotation that exists around the bus still exists on the top-down view as well, and in the bottom left-hand. So now another thing that we're going to be looking at is the scene through time. So obviously this is just one frame within the scene, and the scene exists over a span of time. And so to move through time within this scene, I'm just going to use the arrow keys on my keyboard. So I'm going to use the right arrow key to start moving through time. And so I've only created the annotation on the first frame. So the annotation exists on the very first frame of the scene. And as I move through the scene, we can kind of see the bus in the primary view here, moving down the street, kind of starting to turn the corner here. And so I now want to annotate the rest of this bus along its path. And so there are a couple of different ways that I can do that. So we've got our annotation on the first frame. And what I can do is I can just right click, or I can actually just grab this annotation, and I can use my keyboard Command C to copy that annotation to the clipboard. We can see at the top there that's been copied. Then I can jump, let's say I jump 5 frames ahead, just to where this bus is about to turn the corner. Let's go 6 frames. And then I can hit Command V to paste that cuboid. Now, obviously this is not in the right place. So we're going to click on our cuboid again. And now I want to move this cuboid to where the bus is at the current frame. So previously we selected one of these highlighted regions on the edge of the cuboid to move it up and down. What you can also do is you can hover right in the center of one of the panes on the cuboid. And if I click and drag, that actually lets me move the entire cuboid down. So I can move that cuboid around the bus where it exists on frame 5. And then I can use my panels over here to make any adjustments I need to. One other thing that I can do within this left top and front view is if you look at the top view, now I'm hovering over the cuboid itself. If I move my cursor just outside the cuboid, you can see the cursor's turned into this kind of bent arrow. And so if I hold down my mouse now, if I hold down left click and drag my mouse, I can actually spin the cuboid on this axis. So that can be really useful if I'm pasting a shape onto an object that doesn't quite align. And if I make any mistakes here, so for example, if I'm rotating the axis on the front view of the bus here, this is pretty extreme, but just to prove a point, you can see that now my front view is really off its axis and it's not aligned with the ground anymore. You can come back to the toolbar here and you can use this level cuboid shortcut, or just click on the tool in the toolbar itself, and that re-levels the shape with the ground. So you can make sure that it's flush to the floor. So if we now click outside again, now we've got this cuboid that exists on frame 0. If we go back, frame 0 and frame 5. So I could copy paste this onto every single frame within the scene manually, but that's going to take way too much time. So instead, what we can do is we can actually use interpolation by right clicking on the object where it exists on the first frame, hit interpolate. And this happened pretty quickly, but we can see now in the lower left-hand frame, the lower left-hand labels panel, that this object now exists on frame 0 through frame 5. And if we jump through this scene, you can see that the cuboid has been pasted onto every frame in between frame 0 and frame 5. So a nice and quick way to annotate an object moving through time within the scene. And obviously I got to make some adjustments, but we covered how to do that. So I'll jump into my annotation view, and then I can make any adjustments like this pretty quickly just to make sure I'm capturing the bus in its entirety on each one of these frames. And that's pretty much the end of the product demo for now. If there are any questions, please do drop them in the chat, by the way. We'll do our best to get to all of them. And there were actually a couple of questions that were posted just before we kicked things off. So I'm going to go through those real quickly now. So the first question was, are there any ways to judge point distance from specific points on the grid? For example, judging point cloud height from the ground. Yes, there actually is. So there is a way to do that. Something that we can do is, if I'm not sure, or if I'm having a hard time judging the distance that my points have from the floor, for example, like in the question asked, you can jump into the settings panel here, come down to the scene settings, pop that open, and then there are a bunch of different ways that I can choose to display the point clouds. You know, you can change point cloud size, and in this setting here that says point cloud color, there's a drop down here. So right now I'm just representing the point clouds as a solid color, but you can choose to display the point clouds in varying color depending on what you pick here. So I'm interested in height from origin right now, origin being the ground. So if I select height from origin, we can see that the color of the point cloud has changed. And so the buttons, the points that are further away from the ground are now more red. So it kind of goes from yellow and bleeds into orange and then red, depending on the distance that they are from the floor. So this can make it easier to judge where the points are in relation to the floor. Another question that we got was, is there a way to see the point cloud for the entire scene at once? Yes, really glad you asked that, actually. So this can be really valuable, actually, if you're annotating objects that aren't moving. So obviously the scene is comprised of several different frames, and each frame has a unique scatter of points. So a unique point cloud. You can see the point clouds are obviously changing depending on which frame I'm on for the scene. This makes it easy to annotate the bus as it's moving down the street, but it does make it quite difficult if I want to, for example, annotate something like this tree here. You can't even really tell from the primary point cloud view that this is a tree. But if I use this tool in the top, so you can see toggle merged point cloud view here. So if I select that, it's going to take a little minute here just because there's quite a lot of points. You can see that there are now all the points that pertain to the entire scene. So all the points for each frame within the scene are visible. And that is making it much easier to see this massive tree on the side of the road. So if you're annotating objects that don't move, even parked vehicles, right? Like this truck, for example, has become much easier to visualize. So that's a really effective tool for seeing objects that are stagnant. I'm not seeing any other questions in the chat right now. So I'm going to hand things back over to David, but be sure to check back in with us. We're going to be running these webinars once a month, and there are a lot of exciting other things coming for LiDAR and 3D annotation that we're working on. So if you check back in a couple of weeks, I'm sure we'll have some other tasty features for you to check out.
Great, thank you. So yeah, just to wrap this up, I hope you enjoyed what you saw today. Ncord provides an effective solution for labeling 3D data efficiently, accurately, and importantly at scale, as you saw with all of the different point clouds points scattered about, and we're able to visualize them all at the same time. This can lead to accurate 3D data labels and therefore highly performant models further down the line. And yeah, as Leander already mentioned, we have loads of exciting product updates coming up. So be sure to keep in touch using LinkedIn or our product newsletters. And we will see you in the next demo. Thank you so much for joining.